today's video we're going to work with more examples for arithmetic sequences. So we're going to practice just writing our explicit rules and our recursive rules. And so we're going to start off saying, given this table, write both rules. So I've got when n is 0, we got a -5, 1, we've got a 3, 2, we've got an 11, 3, we've got 19, and then 4, we've got our 27. So first off, maybe you write the rule or write the sequence instead of having it in table format. So starting off, we have a -5. Then our next term is going to be a 3, an 11, a 19, and then a 27. So two important things that you guys want to identify is you want to identify what the A is, or what the first term is. Okay? So figure out what your first term is. Our first term is -5. And then you also want to figure out what your common difference is. Okay, so what's your common difference? So amongst the terms, here we're increasing by 8. Here we're increasing by 8, increasing by 8, increasing by 8. So our common difference is a +8. And so when you are writing your explicit rules, I just put it on a little post-it note for you. Since our n is starting off with 0, this is my rule that I want to write out. So I'm going to say f of n equals, what was your first term? So our first term was -5. Okay. Then you're going to put plus whatever your difference was. So our difference was +8. And then we're going to write our n behind it. And we're going to say 4 n's greater than or equal to 0. Now when I look at my recursive rule, okay, so again, the recursive rule, we're starting off with a 0. So I'm going to say f of 0 equals our first term. So our first term, again, was the -5. And then we're going to write our rule. So we're going to say f of n equals the previous number. That's the notation for previous number. So they're taking the previous number and they are adding 8 to it. For our n's greater than or equal to 1. Okay. On these two examples, they're going to give us a rule and they want us to write the other one. So taking a look at this, they're telling me what my first term is. Okay. They've also told me what my common difference is. So again, since they're starting off with 0, since they're starting off with a 0, I want my equation to look like a plus dn. So I'm going to say f of n equals the first term, so the 9, plus the common difference, which is 8, times n, and we're going to say 4 n's greater than or equal to 0. Now on this one, they've given me the explicit rule, and they want to write the recursive rule. So their explicit rule on this one, here's my first term. I can see my common difference for n times n minus 1, 4 n's greater than or equal to 1. So they want us to write the recursive rule for n's being greater than or equal to 1. So on this one, we're going to say f of 1 equals, so what is their first term? Their first term is 3.1. Then we're going to say f of n, this would let the reader find any next term, is to take the previous number, so that's what this means, the previous number, and they're subtracting 7/10 from it. And I'm going to say 4 my n's greater than or equal to 2, because if they start off with a 1 here, this is always one more on the recursive. All right. Let's look at some other examples. So if I say, let's write out the first 9 terms and then we're going to graph it. So I'm going to go ahead and say f of, they want me to start off at 0. Okay, so I've got my 9 terms. All right, so I'm going to say 6 minus 1/2 times my n, which is 0. So that's going to simplify down to a 6. 6 minus 1/2, and I'm going to plug in a 1. So 6 minus 1/2 is 5.5. Then I'm going to say 6 minus 1/2, our n this time is 2. So that's 1. So 6 minus 1 is 5. 6 minus 1/2 times 3, so that's 1.5. 6 minus 1.5 is 4.5. You can see the pattern now. So 6, 5.5, 5, 4.5. So they are decreasing by 1/2 every time. So you can keep plugging in if you want. So plugging in a 4, 6 minus 2 is 4. Or you can be like, all right, now I know the pattern. This is 3.5. This is 3. This is 2.5. And that's 2. All right, so then plot your points. All right, so we're going to go 0. Oh, that should have been a 1. 1, 2, 3, 4, 5, 6, 7, 8. And then my highest number, I just need to go up 1, 2, 3, 4, 5, 6. So when I was at 0, we got out of 6. When I got 1, we were at 5.5. At 2, we were at 5. At 3, we were at 4.5. And at 4, we were at 4. And then we're going down 1/2. Okay, so then at 5, we're up at 3.5. 6, we're at 3. At 7, we're at 2.5. And then at 8, we're up at 2. Remember, this should be discrete, so we're not going to connect it. And it should look linear. Mine's a little bit off just because I didn't equally space it. But arithmetic should look like a discrete linear function. All right, so this one says write the terms given. Here's your rule. So this is given to me as an arithmetic. And they're telling us 4 n's that are between the 1 and the 5. All right, so they want us to plug in a 1, 2, 3, 4, and 5. So you can do this a couple different ways. One way is that I can plug in the numbers, or I can say like, well, hey, there's their first term. Okay, so their first term is 9. And then they are going up by 2's. So then I can say, all right, let's go up by 2. So that would be 11. I can say go up by another 2, 13, 15, 17. So first term was 9, then they're going up by 2's. If you wanted to make more work for yourself, you could plug in the 1. And 1 minus 1 is 0, times 2 is 0, plus 9 is 9. I could plug in the 2. 2 minus 1 is 1, times 2 is 2, plus 9 is 11. Okay, but I can also kind of crank this out if I recognize that's the first term and that's the common difference. So, writing out the terms in the sequence, we've got a 9, an 11, a 13, a 15, and a 17. So this is finite, because they just said the 1 through 5 terms. Okay. This one says write the first 6 terms given f of 1 equals negative 2.5, and the rule is that they're taking the previous number, that's what that means, and then they're subtracting 1/2. It says 4 n's greater than or equal to 2. So our first number is negative 2.5. The second number, okay, is going to be the previous number minus a half. Okay, so that would give me -3. If I want to find the third spot, I'm going to take the previous number, which was -3, and then subtract a half, so that's -3.5. If I want to find f of 4, I need to take the previous number, -3.5, and subtract a half, so that's -4. F of 5, I'm going to take the previous number, -4, and subtract a half, so now we're at -4.5. F of 6, previous number, -4.5, minus a half is -5. Another way, you could have just started writing out and saying, okay, their first number is -2.5. And then you can say, okay, well, they are subtracting a half. So then that gives me -3. And then you can say, okay, they're subtracting a half again. So that gives me the -3.5. They're subtracting -half again. That gives me -4, and so on. There's my first 6. All right, let's look at this last rule, or last problem. It says that Sally's buying a prom dress on layaway. The dress costs $160. She makes a down payment of $40 to put the dress on layaway. She makes weekly payments of $15. And how many weeks will the dress be paid off, right? An explicit and recursive rule. Okay, so again, since they're wanting us to do an explicit rule for n being greater than or equal to 0, so I need to know the initial amount, and then I need to know what the common difference is. So if the cost of the dress is $160 and she's already put down a down payment of $40, that means that she has left $120. And then if she is making a payment of $15, then from what her balance is, you're subtracting $15, and then we're going to say times n, for n greater than or equal to 0. So there's my explicit rule. Now if I want to write my recursive rule, okay, so my recursive rule is like, well, what is her initial amount that she still has? So she still has 120. What was her common difference? Well, she was paying $15, so she was deducting that from what her balance was, for n greater than or equal to 1. So then it says, well, how long is it going to take for the dress to be paid off? So I'm going to go ahead and use the explicit rule. So this is how much she has after the down payment. And then if we take off the $15 per week, we want to know when's her total going to be 0. So when is the 120 minus the $15 per week payment going to equal 0? So let's subtract the 120 over. So we have -120 equals -15n, divide by -15. And so we get n equals 8. So 8 weeks is how long it'll take her to pay that off.